ideal gas law is an equation of state for a gas. The word state is the condition of a gas at a given time. So PV equals nRT, or pivnert. The gas at a basis equation is said to behave ideally. Again, we're going to assume that all gases act ideally, and we'll talk about at the end of this unit what it means for it not to be an ideal gas, or when is it not an ideal gas. When you use pivnert, you have to make sure that you know that R is the constant, 0.08206 liters times ATM over mole Kelvin. So it's telling you what units you have to be in. Be careful. Not all of the R values that were given to you in Chem 1 are given to you in AP. So just make sure that if you use an R value that has a different pressure, that you're just matching your units. I use 0.0821 liters ATM over mole Kelvin as my R value. You can use one if you haven't memorized. So because I'm using that R value, I'm going to make sure that my pressure is always in ATM, my volume is always in liters, N is always in moles, and T is always in Kelvin. The ideal gas law only holds true when the pressure is less than 1 ATM. Alright, so for example, if 5 moles of nitrogen gas occupies a volume of 11.2 liters, so here I have my N value, I have the gas that I'm referring to, which is a diatomic, I have my volume, and I have my temperature. What volume will 2 moles, so now I'm changing my amount of nitrogen gas occupy at the same temperature and pressure. So we're at the same temperature and pressure. At the same temperature and pressure, hopefully you realize that the volume and moles are inversely related. So really this is not a pivnert problem, this is an Avogadro's law. N1 over V1 equals N2 over V2. So that 0.5 moles divided by 11.2 liters is equal to 2.0 moles divided by X. And so we get an X value of 44.8 liters. Molar mass is used, or molar mass, you should know, is grams per mole. So with the use of the ideal gas law, we can calculate the molar mass, or the molecular weight of a gas, from its measured density. So there's some substitutions that we can do, and we can actually get molar mass to fit into our ideal gas law. So because molar mass is equal to grams per mole, if we were to solve for mole, because that's the common term there, then mole would equal grams per molar mass. So in our pivnert equation, PV equals nRT, we can then substitute grams per molar mass, RT. And then just because it looks kind of weird there, we can rearrange that to PV times the molar mass equals RT. You can also substitute in density. So density is equal to the mass in grams over volume. So if we were, oops, I left out the G there. If we were to take our substitution here and solve for density, then PM equals G over V RT, and so there's my density. So really that would be PM equals DRT. The only one that's given to you in your reference table is the ideal gas law, PV equals MRT. So to use these two, you'll have to understand how to make the substitutions or have them memorized. The way that I like to remember the one with the density is that in the PM you are dirty. That's the way I was taught to memorize it, so that's the way I've memorized it. if you want to remember all of the substitution, you can remember the substitutions as well. Alright, so molar mass would then equal dRT divided by P. If the density of the gas is known, the pressure then is known. Its molar mass can be calculated. So a gas consisting of only carbon and hydrogen has an empirical formula of CH2. The gas has a density of 1.65 grams per liter, so there's my D. 27 degrees Celsius would be my temperature, and then 734 would be my pressure because that's torr. Determine the molar mass and the molecular formula. What you need to realize, different from Chem 1, is that most of these questions are going to ask you to put more than one concept together. So here we have both gas law using Pivnert, and we have empirical versus molecular formulas. So a lot of these are going to ask you to put two things together. Now, because I know the pressure and I know the density, I can use the ideal gas law, PM equals dRT, and solve for my molar mass. It really doesn't matter if you capitalize or lowercase the density there. Now, because I'm using the R value that has Kelvin and ATM, I am going to have to make some conversions. So 734 torr, there's 760 torr to every atmosphere. So that gives us 0.966 ATM. And then 27 degrees Celsius plus 273 gives us 300 Kelvin. So now I can solve for my molar mass. Units really help to make sure that you're correct. So if we look at all of our units and start canceling things out, we have liters, Kelvin, and ATM. That leaves us with grams over moles, which is our unit for molar mass. Alright, so that gives us a molar mass of 42 grams per mole, and that satisfies the first part of the question. The second part says, what is the molecular formula of the gas? So we're going to take our molecular molar mass, 42. We're going to divide it by our empirical molar mass. So carbon plus 2 hydrogens would be 14. And that tells us that our multiple is 3. So 3 times 1 is 3, 3 times 2 is 6. So my molecular formula is C3H6.